So the next thing you have to do is to conduct a significance test for the correlation, and test for, in this case, we'd be testing for a positive correlation. Is that correlation of 0.7 high enough, strong enough to say there's a difference? So I'm going to highlight this data and Control C it, and then if you go to this regression tools tab on the spreadsheet I made for you and just paste in your data. Don't erase the explanatory variable, response variable. You can just paste in your data. Okay. And then if you take a look at the test. So what we're testing is there's HO says the correlation is basically 0. There's no relationship, or that there is a correlation to it. And if you look at this that's the t-score, the t-test for this correlation between. So it's testing this against 0. It gives a t-score 6.4 because we're testing for a positive correlation. We look at the one-tailed area. If we were looking for a negative correlation, we'd be looking at the left one-tailed area too. In the problems that say, is there significant correlation, we'll be looking at the two-tailed. We don't know whether it's greater than or less than. So, but for this problem, I'm looking for that. That's a very small p-value. In fact, it's practically 0 from what I'm seeing. So yes, we're going to reject HO. There is a positive correlation. It's a strong enough correlation to say that there's some linear relationship between those two values. Notice I'm not saying there's a cause and effect relationship. I'm just saying that there's a linear relationship. As we saw, R squared is pretty low, so there's a lot of other issues going on there, a lot of lurking variables. But that's how you conduct your significance test using the spreadsheet. Really easy, easier than the graphing calculator.